Ever since the practice of medicine and other studies in the medical field have started, we have made great progress, even with robotics. We've improved in areas like prosthetics, surgery, and synthesis. For those of you who don't know what synthesis is, it is robotics and humans collaborating together. Why does that matter? Well, it's because there are some prosthetics that have robotics. The price of a prosthetic can range from $5,000 to $50,000. It is said that the first record of prosthetics is in India. It goes all the way back to 3500 BC, where a sacred poem was written and mentioned a prosthetic limb. In 3500 BC, an ancient poem was written called the Rig Veda, and it is said to be the first record of prosthetics. The poem was also written in Sanskrit, which was an ancient language of India. Sanskrit was also used in Hindu scriptures and ancient poems. The Rig Veda recounts the story of a warrior, Queen Vishpala, who lost her leg during battle and later was fitted with an iron prosthetic limb and returned to battle. Remember, a prosthetic is an artificial or non-natural body part, like limbs, a heart, or implants. A prosthetic can also be made from different materials, such as plastic, wood, or metal. In the Rig Veda, it was iron, which is a type of metal. Ever since the invention of prosthetic limbs, people's lives are now easier. Sure, if it's your first time, it may take some time to get used to, but once you are really comfortable with it, you'll be fine. Overall, prosthetics have made a huge impact on people with physical disabilities by making them feel as if they still have their limbs back.
Throughout history, robotics has played a significant role in our lives. One particular field robotics has affected is the medical field. While some may think that medical diagnosis is the only aspect that medicinal robots has affected, it goes beyond that. Before, humans who were dismembered would be unable to use that part of their bodies anymore, but now prosthetics technology has helped to replace dismembered limbs. One particular event in history marks the man now made legend, Gottfried Gotz von Berlichingen. This man was a German imperial knight and a wandering mercenary. Though it wasn't until 1504 AD when Gotz had began his legacy as the man with the iron hand, where a cannonball blast ripped off the lower portion of his right arm. All in all, it was quite a spectacle that he even survived the cannon blast. Wanting to return to the field of battle, he settled to have somebody fashion a prosthetic. But not just any prosthetic. This prosthetic was capable of much more. The iron hand of Gotz von Berlichingen was able to grip anything, whether it was to write or to fight. Prosthetics back then weren't even capable of such precise and intricate movement. The iron hand has thumbs and paired fingers that can be individually locked through a system of elaborate ratchets and spring pawls that are released through pressure on a button located on the back of the hand. The fact that he was actually able to move this hand as if he had no disabilities was astonishing. People need to realize the significance behind the legends that God created through his ventures. Because of his prosthetic limb, scientists all over Europe were able to experiment and dismantle the prosthetic limb, paving the way for prosthetic limbs in the future. Without the incident that happened to Gotz and having to replace his hand with an iron prosthetic limb, we may not have achieved the advanced level of prosthetics we have today.
Throughout the history of robotics in the medical field, prosthetics are not the only well-known aspect covered. Robots are becoming seen more frequently, which is helpful when needed to complete tasks humans can't. Surgeons and medical engineers have been attempting to assemble machines that will be capable of assisting during operations as well as increasing a surgeon's proficiency and dexterity in the field of expertise. Not only are robotics technology used to accurately monitor and tend to a patient when necessary, but now they are used in many different medical fields. With this, we're able to perform more efficiently when using this type of technology. The first documented robot-assisted surgery was in 1985 when the Puma 560 robotic surgical arm was used in a neurological biopsy. With research, discovering a more modern model of a surgery assisting robot, a popular known one is called the RoboDoc surgical system.
Curexo Technology Corporation brings the future of robotic surgery to life with the revolutionary RoboDoc surgical system. RoboDoc means unparalleled precision at a level that completely redefines precision for a new level of patient care. RoboDoc is a proven clinical system. The surgeon can have confidence that it will precisely execute his plan in the clinical setting.
CT study of the individual's patient's joint. Benefits of the RoboDoc system over traditional methods include improved cavity fit, fill, and alignment for prosthetic implants, as well as reduction of leg length discrepancy, intraoperative fractures, and pulmonary emboli. Clinical studies have demonstrated that RoboDoc milled bone cavities and joint surfaces provided for better implant fit, fill, and alignment compared to conventional manual surgery. By using more technology that will become more common, we will be more successful in future procedures. Surgical technology such as the RoboDoc allows surgeons to be sure they're making the correct actions when it comes to
Patients and surgeons are attracted to new technologies with proven benefits. RoboDoc's exclusive open architecture platform enables the use of implants from virtually any manufacturer. RoboDoc reduces the need for additional surgical instruments and equipment. The advantages of the RoboDoc surgical system include high-precision smart tool technology, elimination of less accurate templates and jig-based technology, precise pre-surgical plan execution every time, sub-millimeter dimensional accuracy, precision milling for optimal alignment, 95% bone-to-implant contact, consistent, reproducible outcomes, non-optical technology.
Within surgical technology, surgeries have been able to become done precisely how it's supposed to. Take the RoboDoc for example, created in 1992 by IBM's Thomas J. Watson Research Center and researchers at the University of California. Davis began collaborative development of an innovative system for total hip arthroplasty. The surgical system was the result of collaborative ideas and production. The RoboDoc utilizes the technologies of QRXO Technology Corporation. The OrthoDoc, a three-dimensional workstation that handles pre-operative planning, and the RoboDoc, which itself is the surgical assistant, that is a computer-controlled surgical robot utilized for exact cavity and joint surface preparation that is used during total hip arthroplasty and total knee arthroplasty.
Operative planning is performed on the OrthoDoc preoperative planning workstation, while surgical execution is carried out using the RoboDoc electromechanical arm. A typical RoboDoc procedure consists of the following steps. The first step involves a CT scan of the patient's operative hip joint. The next step involves planning with the OrthoDoc preoperative planning workstation. The CT data is converted to a three-dimensional surface model of the femur. The surgeon selects an appropriate implant and places it along the axes of the bone with the help of anatomical landmarks. The surgeon can manipulate the implant to optimize placement and orientation. Progress. Once RoboDoc has finished preparing the bone, the surgeon proceeds with implant fitting and insertion in the same manner as a manual joint arthroplasty. RoboDoc excels in terms of both precision and accuracy when it comes to correctly placing and orienting the implant. The results from RoboDoc cases speak for themselves.
They're able to be used for surgeries that were once before required surgeons to be paid to travel but can now be performed easier and quicker. Though there are some who are afraid of what robotics technology holds, it's a concept you can't ignore when it's showing just how beneficial it's becoming. My personal opinion about the RoboDoc surgical system is that this particular assisting robot is very essential for common surgeries needed to be done. According to the Centers of Disease Control and Prevention, 332,000 total hip replacements are performed in the United States each year. So with help from the surgical system, we're able to conduct surgery on more patients to live pain-free.
The medical field always wanted a robot that can benefit a surgeon while performing a surgery. From the 1980s of development advancement in microelectronics and computing, 1987 the first laparoscope, and the Da Vinci surgical system broke new ground by becoming the first robotic surgery system approved by the FDA in 2000. It's needed and designed to expand the surgeon's capabilities and offer an state-of-the-art, minimal invasion optional for the major surgery. The robotic system I researched was on the Da Vinci surgical system for robots, in which I will be explaining next. The Da Vinci consists of a surgeon's console. The surgeon operates seated comfortably at a console while viewing a high-definition 3D image inside the patient's body. With a patient cart with 4 interactive robotic arms, the patient side cart is where the patient is positioned during the surgery. It includes either 3 or 4 robotic arms that carry out the surgeon's command, basically like a human's wrist. The cart obtains 3 endo-wrist instruments. All fully range of endo-wrist instruments is available on the surgeon while operating. The instruments are designed with 7 degrees of motion, a range of motion even greater than a human's wrist. Each instrument has specific surgical missions such as clamping, suturing, and tissue manipulation. Quick release levers speed instrument changes during surgery, and one 3D camera called the Vision System. The Vision System is equipped with a high-definition 3D endoscope, flexible tube with a camera and a light at the tip, and the image processing equipment that provides true-to-life images of the patient's anatomy. Also, a view of the operating field is available to the entire or team on a large viewing monitor, Vision Cart. The widescreen view provides a surgical assistant at the patient's side with a broad perspective and a visualization of procedures to access its target in the surgery. It's controlled from the cart, providing the surgeon with precision, dexterity, and control of the traditional open surgery. Its creator of the fantastic manufacturer was an American company, Intubated Surgical System. It was created as a company and group. The benefits of the robotic system is to help the medical field in surgeries because as a human, we can make little mistakes during the surgery. But there is a way to overcome that, which is why the Da Vinci surgical system was invented.
Today, advancements in robotics have come a long way. Procedures that doctors now have to perform have evolved far from what they used to be, when they weren't able as they are today to use orthopedic devices to assist individuals suffering from limb pathology and other disabilities. These devices now are used to increase limb strength and stability. Neurocontrol of wearable robotics means neural interfaces operate where the nervous system and an artificial device intersect. Interfaces can monitor nerve signals or provide inputs that let NLPs control prosthetic devices by direct neural signals, the same way they would control parts of your own body. Robotics truly are to better our growth and health in our society. Scientists test their theory of neural control of wearable robotics on people who can't move or no longer have control over a limb because of an accident or genetic defects. Hatakina Ngwala of the Asahi Symbol and Globe said his legs will be covered in metal braces. Actually, a wearable robot that performs movements such as standing and walking by simply visualizing them mentally. The young man is a paraplegic who cannot move his legs at all. His brain will control the robot and enable him to walk. And when he kicks the ball in the field's center circle, a huge cheer will erupt from the crowd. This project is being led by Miguel Nicolas, 53, a Brazilian national and professor at Duke University in Durham. He is a leading authority in brain-machine interfaces, BMI, a technology involving the use of neural signals to control devices. The Brazilian government is also supporting his project as a means of displaying the country's scientific and technological capabilities to the world. This man wasn't able to move out of his chair before. With robotic replacements, he was able to play soccer and inspire many people who struggle with these conditions to not lose hope. We have finally found a solution to help demolish the factors holding them back before.
Neuroprosthetics aren't just legs. Scientists have developed more to help people. They've created prosthetics for arms and even reconstruction of heart. Prosthetics have helped with hundreds, from wounded soldiers to your great-grandparents, to that little boy who can't walk in the hospital. Robotic use in the medical field has only begun to prosper and truly help where doctors before couldn't. The neural control of wearable robotics has today advanced for the better.
We're going to not stop at just arms and hands. I think that it's going to open the way for things like sight and sound. And my dream that we'll be able to take this into all sorts of patients with stroke, patients with cerebral palsy, and the elderly.
I think when other quadriplegics see what I'm doing with the arm, they're all going to say, oh, wow, I wish I could do that.
That's the way I like to get cookies. Awesome. Thank you so much.
I just feel very honored to be the one who gets to do it.